Okay, hello class. Our first problem today is going to be number 3 over here. A fair die is tossed 5 times. Find the probability of tossing A at least 4 even numbers and B at most 3 sixes. So to start with 3A, we're going to use a probability equation. P of at least 4 equals P of 4 plus P of 5. So now we're going to use our NCR P to the R Q to the N minus R formula, where N is going to equal 5. R4 in the first equation, R5 in the second. P is going to equal 1/2, and Q, which is going to be the difference of 1 minus P, is going to also equal 1/2. So now to put this in, we're going to translate the P to the 4 plus P to the 5 into those NCR P to the R Q to the N minus R formulas. So 5 C4 times 1/2 to the power of 4 times 1/2 to the power of 1 plus 5C5 times 1/2 to the power of 5 times 1/2 to the power of 0. Now this is going to become the following. 5 factorial over 1 factorial over 4 factorial, which simplifies down to 5. Multiply this times 1 over 16 times 1/2. And now we're going to add that to 5 factorial over 0 factorial, which is 1, over 5 factorial. And this all simplifies down to 1, times 1 over 32 times 1. So then this becomes 5 over 32 plus 1 over 32. And this ends with 6 over 32, which simplifies down to 3 over 16. So next we have 3b, which is going to be at most 3 sixes. We're going to use that probability equation again, which will give us P of at most 3 equals P1 plus P2 plus P3. And now we're going to use the NCR P to the R Q to the N minus R formula again. And we're just going to do the same thing where we transpose that to these 3 probabilities over here. So now the N is going to equal 5, the R is going to equal 1 in the first equation, the R will equal 2 in the second, and the R will equal 3 in the third. The P will equal 1/6, and the Q, since it is the difference, 1 minus P, will give us 5/6. So now this becomes 5C1, 1 over 6 to the first, 5 over 6 to the power of 4, plus 5C2 times 1/6 squared times 5/6 to the third plus 5C3 times 1/6 to the third times 5/6 squared. Now 5C1 is going to simplify down to 5 factorial over 4 factorial over 1 factorial, which becomes 5. Now we multiply that times 1/6 to the first, which is equal to 1/6, times 5 over 6 to the power of 4, which becomes 625 over 7,776. This will all become 3,125 over 7,776. Now we add 1,000, the 5C2 is going to simplify down to 5 factorial over 3 factorial over 2 factorial, which becomes 10, times the 1/6 squared, which is 1 over 36, times 125 over 216. And that all becomes 1,250 over 7,776. Now we add that to the 5C3, which becomes 5 factorial over 2 factorial over 3 factorial, and that simplifies down to 10, times 1/6 to the third, which gives us 1 over 216, times 5/6 squared, which is 25 over 36. And this becomes 10 times 25 over 7,776. And that gives us 250 over 7,776. Add these 3 values together, and we get 4,625 over 7,776. Okay, so now we have our Final problem. If sine of x equals 2 radical 13 over 13 and tan of x is negative, find all of the remaining trig functions for angle x. We're going to start by creating a cast chart. So as we know, sine is positive, tan is negative. The only way this will work out is for quadrant 2. Now we're going to create a right triangle with respect to angle x. As we know, sine is equal to opposite over hypotenuse. So our sine in this problem, as given, is 2 radical 13 over 13. So that means that this opposite here will be 2 radical 13, and this will be 13. Now, our adjacent is unknown. We're going to use the Pythagorean theorem to figure that out. A squared plus b squared equals c squared. The a squared is going to be 2 radical 13 squared, and that's going to be equal to 52, plus b squared, we're going to leave it the way it is. C squared is going to be 13 squared, which is equal to 169. We're going to subtract the 52 on both sides, and it's going to give us b squared equals 117. We need to take the square root now. B is now equal to radical 9 and radical 13. So, as we know, radical 9 is a perfect square. So b equals 3 radical 13. We're going to leave the radical 13 alone. Now, we can place this where it belongs, and we can start solving for our other trigonomic functions. Cosine of x is equal to the adjacent over the hypotenuse. The adjacent, as we know, is 3 radical 13, and we're going to put that over the 13. Now, since our sine should be positive, nothing else will be, except for cosecant. So this is going to be negative. Next, we have tangent of x, which is equal to opposite over adjacent. And this is going to equal 2 radical 13 over 3 radical 13. We can simplify this down just to 2/3, and it's going to be negative. Next, our cosecant, which has a direct relation to our sine, so it will be positive. It's the reciprocal. Will be hypotenuse over opposite. And this will give us 13 over 2 radical 13. We need to rationalize the denominator. Make this 13 radical 13 over 26. And this gives us radical 13 over 2. It's going to remain positive. Now we have our secant, which will be negative, and it's going to be hypotenuse over adjacent. So that's going to give us 13 over 3 radical 13. We need to rationalize again, and that's going to give us 13 radical 13 over 39, which equals radical 13 over 3. Now finally, our cotangent of x, which equals adjacent over opposite, as it is the reciprocal. So then we're going to just do negative 3 over 2. And there you have it. That is the finished product. And those are the remaining trigonomic functions. Thank you. I hope you learned something today. Or not. Maybe you know more than me. God bless.